So what's an atom?
An atom is, something that builds up everything.
Atom. Oh, that one. The small particle, isn't it?
Atom, that's a very small particle.
An atom was the smallest indivisible part of an element.
You can further divide an atom into protons and neutrons.
Protons and neutrons, is that it?
It's just a small little thing that's made up of protons, electrons and a neutron.
All of the materials and things are made up of atoms, and then you've got the nucleus and the electrons that go around the outside. That will be an atom, which is made up of the nucleus and electrons. There can be dozens of these electrons whizzing around in different orbits, and it's mainly nothing.
This is how it's represented.
Yep.
There's the proton, and that's the electron, and then you have a neutron in there as well. And this thing spins around, but
So it seems most people are comfortable with the idea that all matter is made up of atoms, that an atom is the fundamental building block of matter, and that these atoms are made up of smaller particles called protons, electrons, and neutrons. But after that, the details get a little bit hazy. It looks a bit like Saturn.
It does. It looks very much like Saturn.
So what I'd like to do is actually build an atom, or at least a model of an atom. So I've got here proton, neutron, and electron. The simplest atom that I can make is hydrogen, because hydrogen consists of only two particles, a little positive proton and a tiny little negative electron. They're attracted to each other because of their opposite charge. And so many people think of the electron as orbiting about the proton. That's not strictly true. I mean, it's not like a planet going around the sun, but because the proton is positively charged and the electron is negatively charged, they're both attracted towards each other. Now, what would happen if we took our hydrogen atom, which consists just of a proton and an electron, and we added a neutron into the nucleus? This hasn't really changed anything electrically because the proton and the electron are still opposite charges and attracting each other, and the neutron is neutral, so it doesn't really affect this interaction. So the atom that we have here is still hydrogen, except it's just a little bit more massive. You could say it's heavier because the neutron is there. But how does that really affect the behavior of this atom? Well, the truth is, it's not that different to regular hydrogen. And this is what we call an isotope. An isotope is a different version of the same element. So it has the same number of protons in the nucleus, but just a different number of neutrons.